Hello, and thank you for watching our short presentation on using TIPS well log modeling software for performing well ties and identifying multiples in your seismic data. TIPS well log modeler, that is Toolkit for integrating Petrophysics and Seismic, was developed by Dr. Fred Hilterman initially for his student classes at the University of Houston. TIPS contains all the key modeling features available in the popular rock physics modeling packages for an exceptionally low price, so please contact us to find out more. You'll discover it's very easy to check your seismic for multiples using TIPS. Just send an email to tips@geotomo.com and we'll provide you with a 30-day free trial, including access to easy-to-follow training videos. And if you discover that multiples are complicating your interpretation, we'll be delighted to talk about our multiple suppression services, which can be applied to your stacked data. In this short presentation, we will review the different types of synthetics which can be generated using TIPS, discuss the effect of multiples and lithostratigraphic events, describe the basic workflow for performing well tie analysis, and finally we'll review 3 well tie examples. Okay, let's review the types of synthetics available in TIPS. In TIPS, you can very easily and quickly generate the following: zero offset synthetics with primaries only and primaries plus multiples, offset, also known as aviosynthetics, both gathers and stacks, stacked created from aviosynthetics with variable mutes, and you can include fluid effects for both zero offset and aviosynthetics. Zero offset synthetics. Importing and preparation of log and well information is simple to do. Sonic intensity logs are used to calculate the reflectivity series, which is then convolved with a wavelet, either predefined or extracted from seismic. Display options include primaries only and primaries plus long and short period multiples. Offset or aviosynthetics are used to model the effects of real seismic data, which of course is acquired using offset source locations. Offset ray paths can give rise to what are known as lithostratigraphic events, which, like multiples, can also complicate interpretation. More on lithostratigraphic events shortly. Aviosynthetics also require a shear log. If you don't have a field shear log available, you can easily generate one in TIPS from the sonic, density, and the gamma ray logs. Offset gathers are computed using the 3-part Shuey equation based upon P wave, shear wave, density, and reflection angles. In TIPS, you can observe how varying lithologies and fluids affect reflection characteristics in the near, mid, and far sections of the gathers. Each part can be displayed separately and summed. This synthetic gather shows how reflection characteristics change with offset. Also shown is a near offset stack computed with a 0 to 10 degree mute. The near offset stack, of course, is equivalent to the zero offset synthetic discussed earlier. Physics of AVO is beyond the scope of this presentation, but suggested reading on this subject is Dr. Fred Hilterman's SEG book entitled Seismic Amplitude Interpretation. A very useful feature in TIPS is the ability to generate stacks using different mutes. As well as being able to generate near, mid, and far stacks for traditional AVO analysis, interpreters might wish to experiment with varying the mutes when tying wells for interpretation, because during processing there are a number of reasons why the processor may have chosen the mutes which were actually applied, and these may not actually be known to the interpreter. So these two stacks show, for example, a noticeable difference where one was generated with a 10 to 50 degree and the other a 0 to 30 degree mute. If known, fluid zones can be included with respect to both zero offset and aviosynthetics. Fluid types may include brine, gas, oil, and fizz gas. Now, multiples and lithostratigraphic events. These cartoon diagrams show ray paths of surface-related multiples, long-period multiples, and short-period multiples. Surface and long-period multiples add events, while short-period multiples delay and distort the wavelet. TIPS allows the user to display primaries only, primaries plus long and short period multiples, and primaries plus surface reflection multiples. This synthetic AVO gather shows how reflection characteristics of geologic boundaries can vary with increasing offset, hence the AVO effect. In this case, the shale break in the sandstone creates an AVO effect on the mid and far offsets. These are known as lithostratigraphic events. Events on the near offsets are not affected and are known as chronostratigraphic events. Note that AVO effects can occur across lithologic boundaries with or without the presence of fluids. As a test, we modified the shale volume curve to remove all of the sandstone, and notice the change in the corresponding Young's modulus curve, denoted as sigma. See how the lithostratigraphic events have been removed. Of course, zero offset synthetics only model chronostratigraphic events. Again, with the sandstone layers in the shale volume, and without. Due to the presence of lithostratigraphic events, there can be significant differences between a zero offset and an aviosynthetic. More on this in our well ties examples. Okay, so let's go through an example workflow for well log preparation and generation of synthetics. So in TIPS, it's very simple, very quick to load LAS files, deviation data, and checkshot information, and this is easily accomplished using the TIPS import wizard. Organizing, visualizing, and editing logs is simple and intuitive. The orange zones show gaps in the imported logs which will need to be filled in order to generate synthetics, and a complete suite of editing functions is available, and new curves may be calculated as required. Sonic and density logs are required to produce zero offset synthetics. Any gaps in the sonic log may be filled in using edit functions or a calibrated resistivity. If needed, the entire sonic log can be generated from a resistivity log. Similarly, a gamma ray log may be used to fill in a density curve or substitute the entire curve if necessary. The clip on the left from TIPS shows a sonic log interval being generated from its resistivity using the calculate option. On the right is a workflow required to generate a density interval starting from the gamma ray and the sonic, or its inverse, the P wave. A shale volume is calculated by picking the upper and lower limits of the gamma ray log to define the sandstone shale percentages. The shale log may be generated from an SP log also. Note that other lithologies may be included in the shale volume curve as required by your geologic region. Finally, the density curve is generated from the P wave and the shale volume curves. For aviosynthetics, we need a shear log, and if a field log isn't available, simply input the P wave, the shale volume, and the density that we've already made available, and then select the Greenberg-Castagna method to generate the shear log. Known brine saturation zones and pore fluid types may be entered interactively along with their various properties including water saturation, gas-oil ratio, API, temperature, etc. If available, density porosity and neutron porosity are commonly used to identify gas zones. In TIPS, the two logs can be displayed together with the scales reversed. Overlap zones are highlighted in yellow and may be interpreted as gas zones. Once the P wave and density logs are prepared, the zero offset synthetic window automatically becomes available. Wavelets may be extracted from Seismic or chosen from predefined selection, and phase can be adjusted. Displayed here are primaries only, primaries with multiples, and primaries with surface reflection. Once the shear log is available, the aviosynthetic window is automatically available. Angle mutes can be displayed along with a user-defined angle stack, and various inversion curves can be calculated. In this case, the normal incidence, Shuey, and Poisson's ratio are shown. This slide shows the in-situ synthetic along with the fluid substitution synthetic. Fluid substitution can be performed in order to test the effects on gathers, stacks, and the inversion curves. Now, here are two simple tests that you can perform using TIPS to determine whether your geology actually has the potential to produce significant multiples. So firstly, check if there is a significant difference between primaries only and primaries plus multiple synthetics. Of course, if you see a significant difference, then internal multiples are most likely present in your data. Secondly, chopping the well log depths will show any multiple trains on the primaries plus multiple synthetic. In this case, the continuation of multiples beyond the end of the well log model indicates the source of the internal multiples. Now we're ready to import seismic data and start performing well tie analysis. 2D seismic or inline crossline sections from 3D may be imported by a SEG. You can choose to display zero offset primaries only or primaries with multiples. You can extract a wavelet on the fly or select a predefined wavelet and modify wavelet frequency and phase. You can also display abiosynthetics, modify stack mutes as you go, and show the various stacks. Now here is the first of the 3 well tie examples. In this example, we begin by testing primaries only with extracted wavelet, zero phase. Not a great match, as you can see. Next, we try primaries plus multiples with extracted wavelet rotated 100 degrees. Now look at the significant improvement in the seismic to synthetic well tie. A simple stretch and squeeze would produce a wrong answer. In this example, we show a far offset stack created using the offset range from 1200 to 1800 meters next to a zero offset synthetic. Not a good tie. Here we insert the near offset stack created using the 0 to 600 meter offset range. This shows a much better tie. The far offset seismic must contain lithostratigraphic events, which clearly do not tie with the zero offset synthetic. In the third example, we show the shale breaks in the sand units and the corresponding lithostratigraphic events on the gather. Now, how would the top Namur match the seismic? The seismic is stacked using the full offset range and therefore contains significant lithostratigraphic events. The zero offset synthetic shown does not contain lithostratigraphic events and therefore does not show a good tie with the seismic, as can be seen with the top Namur. The abiosynthetic, shown here, is created using the full offset range of the synthetic gathers and therefore captures all of the lithostratigraphic events as well, and consequently shows a good tie with the seismic. Now the top Namur ties very well. So in this introduction to TIPS, we reviewed the generating synthetics in TIPS. We talked about multiples and lithostratigraphic events. We showed a workflow for well tie analysis, and we showed 3 well tie examples. So we invite you to download TIPS and test your own seismic data. If you would like to do so, please just send us an email to tips@geotomo.com, and if you do identify problem multiples, then we will be delighted to contact you and discuss how we can help. Thank you very much.